back to Cracking the Cryptic, where we've been asked to take a look at this Killer Sudoku from the Observer last weekend. So the Observer is the Sunday edition of the Guardian, basically. I've never done Killer Sudoku from the Observer before, so I've got no idea how hard this will be. But let's see. So we can fill in one of the three options for the 4 cage. You can write in the value of this cell. I can immediately see that. So the way we do that is to look at the fact that we know this 3x3 block in the bottom right adds to 45, because it will contain the numbers from 1 to 9 exactly once each. So we've got a 20 cage plus a 16 cage already within this 3x3 block. That sums to 36. So in order to get to 45, I know these two cells will have to add to 9. These two cells add up to 9 and they're part of a 10 cage. This cell here has to be a 1, so let's write that in. Interesting to note, just looking at this top 3x3 block here, a 1 can't go in this 26 cage, because if it goes in the 26 cage, the other 3 numbers would have to add to 25, which is impossible. 7, 8 and 9 add to 24, so the 1 is sort of locked into one of these 3 squares. Let's just think about this a bit more. So we now know they've got this 1 here, this 21 and this 11. If we add all that up, we get 33. So I know these two cells add to 12 and these two cells sum to 9. And if one of them's a 1, the other will be an 8. So we'd be left with 1, 8 and 3. Still looks doable. 28 cage I don't think has to contain an 8. No, it doesn't. So we'll have to come back to that. So what next? 3, 3. Well, we can actually write in the value of this cell here. It's a bit convoluted, but if we look at the 4 3x3 boxes that form the sort of bottom left part of the grid, you can see that the only cage that sticks out of this massive square is this one. So let's add up the numbers here. We've got 10, 28, that's 38, plus another 30 there, that's 68, 89, 101, 122, 143, 151, 170, 80. So this slot here have to add to 10, and this must be an 8. Let's write that in. So that's useful actually, isn't it? Because now this can't be 1 and 8, because this cell can take neither of those things. So this must be the 1. This must be, oops, not a 2. This must be a 3. Like that. This 3 is interesting, maybe. Let's just try and use it on this bottom 3x3 of the grid. You can see it eliminates 3's from this cell, and this cell very clearly. But this 6 cage is nice because this can't contain a 3 either. Obviously, if it had one 3, it would have a second 3, and that would break the rules. And this 28 cage can't contain a 3 for the same reason that the 26 cage over here couldn't contain a 1. This contains a 3, it can no longer be filled because we can only get to 25 with the other 3 numbers. So that means I think that the 3 is in one of those 2 positions. Now, if that's the case and we know there's no 3 here, then this 18 cage also contains a 3. So that means that the other 2 numbers in here have to add to 7 without using 3. So it's either 1 and 7 or 2 and 6. And you can also see that depending on what we add to this value, this 15 cage in this box, let's just pick a number, let's say we add a 1. So this would be 1, 3, 1, 3. That would mean these have to add to 11. 11 plus 12 plus 21 that would make this have to be a 1 in order to get to 45. And so there's actually a symmetry here. Whichever number we add to the 15 cage in these two cells is going to be mirrored in this position. Now, annoyingly, we can't actually eliminate anything from this cell at the moment. So, you know, if this was a 9, this would be a 9, and that's still absolutely fine. But that might come into play later, I think. And the other thing I can see is there's a relationship between this cell here and this cell, because we know that the left-handmost 4 columns of the grid will add up altogether to 180. So let's just do some arithmetic here. So we've got 14 and 20 is 34, 46, 53, 63, 82, 90, 111, 12, 132, 132, 144, 145, 165, 180. And that's interesting, isn't it? So whatever the value of this cell is, it has to be mirrored here. So that's interesting, because that means this cannot be an 8 or a 3. Now, a 28 cage has to contain an 8 somewhere within it, because if we think about the other highest options, it would be 9, 7, 6 and 5, which adds to 27. So given there must be an 8 in here, and there cannot be an 8 here because of this parity with this cell, this has to be an 8. Let's just, now we can think about column 6 maybe. This 9 cage, what can the options be here? It can't be 1, 8, could be 2, 7, can't be 3, 6, could be 4, 5. So it's either 2, 7 or 4, 5. Well, whichever way it is, it's going to contain a 2 or a 4. That means this 6 cage must be 1, 5, because the 2 or the 4 will be appearing in the 9 cage. Now what we might be able to do is hone in on the value of certain combinations that are appearing in column 5 by using the totals for column 5 and 6. Now, we know columns 5 and 6 together will add up to 90. So let's just do some arithmetic here. 16 plus 3 is 19, plus 18 is 37, 10 is 47, plus 9 plus 6 is 62, plus this 8 here is 70. So I know that this cell, and this cell sum up to 20. Now if these sum up to 20, this cell, and this cell must sum up to 20, 28, 11. So I'm getting that by going 20 plus this 8 here, 28, plus this 6 is 34. So I know that the other 3 cells must sum to 11 to give me 45 in the column. And this 11 total is including a 3. So that's brilliant, because that means that the other 2 numbers must be 2 and 6, because 1 and 7 is ruled out by this 6 cage. So we're starting maybe, so I think we get 2, 3 and 6 into these cells here. Now, can we go further than that? Well, must have 4, 7 and 9 in the other position. So again, let's write that in. So that I think means this 28 cage is filled with the numbers 4, 7 and 9. Because if there isn't a 4 in the column here, in either of these 2 positions, the numbers will be 7 and 9, and that will force a 4 into this position. So this 28 cage is of the variety 4, 7 and 9. And we need to remember that this 9 cage here is either 2, 7 or 4, 5. So that's either going to rule out the 4 from here or the 7. So this square here will have to be 4 or 7. It can't contain the 9. And then we can use this 18 cage to make more progress, because we know there's a 3 in one of these two positions. So we worked out already, I think, that this number and this number are going to have to add up to 7. Now we know that the options for that number now are either 6 or 2, so this is either 1 or 5, I think. So that's quite restricted as well. And now column 6 is getting really congested. Let's just look at the options here. If this is a 2, these have to sum up to 14 without using an 8. So this would be 5 and 9. That would make this a 1. This 10 cage would have to be 4 and 6 because it's the only option left for it, and this would have to be 2 and 7. If on the other hand this is a 6, these two have to sum to 10 without using a 6 now. So this would have to be 1, 9, 1, 9. That would make this a 5. Again this is 4, 6. Again this is 2, 7. So there we go. We've actually made a lot of progress there. There is definitely a 6 in this 3x3 block, so we can eliminate these two 6s here. This is going to have to be a 6 after all that, and that is really going to blow the puzzle open. So 6, we can remove the 5s, we can remove the 1 here. This has to be a 5. This has to be a 7. That. This down here must be 3 and 6, and we remembered that when we write the 6 in here, this has to be a 6 over on this side. These adding up to 9 means these two add up to 6 without using 1 and 5, so this in fact has to be 2, 4, 2, 4, which means this is a 7 and this is a 2. Just fill in some of the options down the sides here. So we've got 189, 189, 189. Oh, this can't be a 1, so it's going to have to be 8 or 9 there. That means this is a 4, this is a 9, just by simple Sudoku rules. And we've got 2, 5, 7 into these three positions. 2, 5, 7, 2, 5, 7, 2, 5, oops, 5, 7. So this can't be, this has to be the 4 over here. This 14 cage now is very restricted, so these add up to 10, so this is 3, this can't be a 5 anymore, this is a 3 or an 8. I mean, I think we're almost there. We'll just do a couple more numbers just to prove that we've cracked the puzzle, but I don't think there's any value in me, solving the very simple stages. It's not going to make for a good video, so let's just see if we can make 1 or 2 more deductions and then we'll be done. Maybe this 21 cage. So this 21 cage, how do we make 21? Well, the biggest option would be 9, 8 and 4, and that's obviously not possible because this can't take any of those numbers. And it must contain at least one of those numbers because 7, 6 and 5 isn't big enough. So let's say that this is this contains an 8 but not a 9. If this contains an 8 but not a 9, it would have to be 8, 7 and 6, which is impossible because there's already a 6 in the box. So this, in fact, this 21 cage does contain a 9 and not an 8. Now if it contains a 9 and not an 8, we need the other two numbers to add to 12 without being 3, 9, without being 4, 8. So the other two numbers are 5 and 7. 7, 5, 7, like that, which means down this side we must have 1, 3 and 8 to make this 12 work. And then we can use column 1 now. So we know column 1 will add to 45, and we've got some boxes sticking out from column 1, i.e. if we add this 20 cage, this 8 cage, this 21 cage and this 12 cage, we'll be able to isolate the values of these 3 cells. Let's just do that. So 20, 28, 49, 61 I think. So we know these 3 cells add to 16. Well, 16 plus 12 is 28, plus 6 is 34. So this cell, and this cell have to sum to 11. So this can no longer contain a 9. That's definitely true, which means we've managed to work out this is the 9 now. And if this was a 7, then this would have to be a 2 and a 2 here. So we'd have a repeated 2. So this isn't a 7 either. This must, I think, be a 5. That's a 7. And this is a 2 or a 4. And you can see we're really making quite a lot of good progress now. 5 5s into those positions. Can remove the 1 here. 1 2 3 5 along here. So this is 2 3 or 5. Can't be a 1. This 1, so this is a 7, a 6, or a 4. You know, where does the 9 go in row 9 now? You can see it's got to be over in the 16 cage. So there's no 9s over here. So that means the other 2 numbers will have to add up to 7 without being 2 and 5 and without being 3 and 4. So that's going to have to be 1 and 6. And you can see actually that's going to be really useful. The 1 therefore will have to be here. 1, that can't be a 1. This can't be a 6 anymore, which means this can't be a 3. This must be a 3. This is a 6. This must be an 8, 3, 1, like that. And we've got 4, 7 and 8 into these positions. This 12 cage now can't be 5 and 7, can't be 4 and 8 because we already have a 2 4 pair in the column. So this must be 3 9 3 9, which means this must be an 8. This must be a 2. Because there's 12 in this 17 cage, these 2 squares have to add up to 5 without using 3. So this is 1 and 4, 1 and 4, which is resolved by the 1 over here. That means this is 2 and this is 4 and this is 2. So these add up to 8, which means these 2 have to add up to 13. Can't be 9, 4 now, so it must be 8 and 5. With 3 and 6 to complete this 19 cage look. 3 and 6 add up to 9, these 2 have to add up to 10, that's working. Okay, so that gives us that. This 8 cage now must be 1 and 7, which can only go one way round, must be like this. So 7, this must be a 7 now up here. This 1 and 9 is resolved. And yeah, I mean, I think we're there. I'll leave the rest of it as an exercise for the viewer. I hope this was a useful run through. I thought it was quite a good puzzle actually. It took a little bit of thought to crack at the beginning and was a very good reminder of some of the key techniques that can crack these more difficult killer Sudokus. So thank you for watching. If you enjoy the content, please do subscribe to the channel. We really appreciate it. We'll be back soon with another edition of Cracking the Cryptic.